Phone dead. Grid gone. You're standing with a bag of trash and one rule. Get the phone alive long enough to call, text your location, or light your way. No fluff, no miracle promises. Just physics, tools you can carry, and discarded parts that behave like a parts bin if you know the rules. Safety first. Stop and read this. Anything electrical can hurt you or start a fire. I'm not going to show you how to gut lithium packs and wire raw cells together. If you work with batteries, use protective gloves and eye protection. Always include a fuse and prefer pre-built modules, sealed power banks, USB boost modules, or a verified battery management system, BMS. Don't scavenge inside hazardous or restricted sites. Don't touch corroded or swollen batteries. This is emergency triage, small, safe boosts to get you moving. Here's the simple electrical primer you need. Phones charge from a USB voltage, roughly 5 volts for standard USB. Voltage tells the phone it's connected. Current, amps, is what actually fills the battery. You'll get one or the other wrong and the phone either won't charge or you'll damage something. The connector matters. A loose or broken USB plug is as useless as no source at all. So when I say supply 5 volts at usable current, that's the target. Nothing mystical, just voltage, current, and a solid connector. Pocket kit you want to carry or improvise from bits. A small multimeter, a USB cable, preferably one that fits your phone, a short screwdriver, electrical tape, a small consumer USB boost module or intact power bank if you can find one, a short inline fuse, 1 to 2A for phones, a couple of AA or AAA cells or sealed batteries if available, and basic PPE, gloves and safety glasses. That's it. Minimal, lightweight, high ROI. Think of these approaches as 3 tiers: salvage, convert, harvest. Start simple. Move deeper only if you have the right parts and the discipline to be safe. Method 1. Salvage and reuse. Fastest, lowest risk. Trash is not an enemy, it's a parts bin. Look for intact power banks, old phone chargers, USB garden lights, Bluetooth speaker packs, or any device with a USB output. Those PCBs often have the exact electronics you need already protected behind their case. Your goal here is to find a module that already does the heavy lifting. It outputs around 5 volts and has internal regulation and protection. How to spot usable gear quickly. Intact enclosure, USB port present, no obvious burn marks or melted plastic, battery not visibly swollen. Smell is a crude test. A burnt smell means leave it. If you have a multimeter, confirm the USB port reads roughly 5 volts with no load. That alone is a strong signal the board may be salvageable. If you find an intact power bank or a device with a working USB port, the workflow is short and safe. Check the port voltage. If it reads 5 volts, plug in a cable and connect the phone. Watch the phone's charging indicator and your meter.
Typical numbers: a healthy power bank will show 5V and somewhere between 0.5A to 1.8 under load for modest units. In an emergency, even 0.3, 0.5A will buy you valuable minutes of charge. Don't promise a full refill. Think in terms of a boost, often a few percent up to maybe 20–30% depending on capacity and condition. Use the phone while charging? Don't. That bleeds current. Keep it on airplane mode, low brightness, and the screen off. If the port is physically broken but the PCB looks intact, a safe alternative is to remove the circuit board into a clean insulated container and use a pre-made USB breakout cable to tap the 5V GND pads, but only if you know how to identify pins and insulate connections. If you can't confidently identify the pads, don't try it. The safest move is to find another item. This method gets you to a usable charge fastest because it nudges you toward pre-manufactured protection. That's the point. Use what already has the safety built in. If you want a printable, safe scavenger checklist that lists things to look for and what to avoid, I've got one in the description. If this is useful, hit like and grab that checklist. It's the only CTA I'll drop early. Now back to work. Method 2. Convert. Moderate risk, better results if you're careful. This is for when you have a few loose cells or small battery packs and a basic toolkit. Think AA cells, NiM rechargeables, or loose 18650 salvaged from old laptop packs. Important rule: do not reassemble lithium-ion cells into new packs unless you have a proper BMS and a safe enclosure. I will describe safe modular ways to use cells without instructing dangerous rewiring. Option A. AAA cells plus USB boost module. Many cheap boost converter boards exist that take 3 to 6V in and output a regulated 5V USB. These boards are low cost and widely available. If you have AAA NiM cells, arrange them in the correct holder, secure a short fuse inline, connect to the boost module, verify polarity with a multimeter, and then test the module with no phone connected. Confirmed 5V out at the USB jack. If stable, plug the phone. Expected output varies. A single boost module may supply 0.51A depending on power source. Practical outcome, a pack of 9 AAs can give several hundred milliamps through the converter, enough for a short call or a location ping. Troubleshooting. Phone won't charge? Check polarity. Check the boost module is enabled. Some have an on-off pad or a load detection feature. Measure voltage under load. If voltage collapses, the cells are weak or miswired. Option B. 18650 cells with proper management. 18650s are tempting. They pack energy, but they're also a hazard if shorted, punctured, or mismatched. Only use 18650s if the cells are undamaged and you plan to use a pre-built holder and a verified BMS or a sealed commercially available battery pack enclosure. Don't wire multiple lithium cells in series without cell management.
The safer approach is to use a single 18650 with a boost converter module rated for lithium input. That yields 5-volt USB safely. If you have multiple cells, use only in a manufacturer-approved battery pack or a pre-built assembly with a BMS included. Always include a fuse, and never charge cells individually without proper balancing and protection. A few practical numbers. A single good 18650 is around 2,000–3,000 mAh nominal. Through a boost converter and losses, a conservative usable output might give your phone a noticeable emergency bump, but treat this as conditional and prioritize safety. If uncertain, use AA cells or an intact power bank instead. Wiring basics to keep safe. Always confirm polarity with a meter before connecting. Insert a fuse on the positive lead between cells and converter. Secure all connections and insulate exposed wire. If the multimeter shows a steady 5-volt at the USB port and no smoke, you're in the green territory. If you see voltage fluctuations or heat, disconnect. Method 3. Harvest. Low power, low risk sources when batteries are unavailable. Sometimes you have no batteries, only movement, sun, or heat. Harvest methods are slow, but they can trickle charge a phone enough to boot it, send a message, or extend uptime over hours. Hand crank dynamos and cheap bicycle dynamos can produce usable voltage when spun at reasonable speed. Use a commercial dynamo with a rectifier and a small capacitor or a charge controller to stabilize the output before feeding a USB boost. Expect low current, often under 0.5A unless you crank hard. Useful for short bursts. Solar panels from garden lights or discarded solar yard modules can be repurposed. Many of these are 5 to 6 volt nominal and can be wired to a small charge controller or a USB boost circuit configured for the raw panel. Again, the panel alone is not a protected source. Use a commercial solar charge controller or a sealed USB solar module whenever possible. In bright sunlight, these can top off a phone slowly. Thermoelectric generators, TEG, attached to a cook stove or even a warm metal can produce a small voltage difference across hot and cold sides. For safety and practicality, use off-the-shelf TEG kits with manufacturer-specified wiring and a voltage regulator. These are neat for extended low-power operation, but not for instant charges. Across all harvest methods, the common theme, low power, patience, and a stabilizer between source and phone. Don't connect raw, fluctuating power directly to your device. Realistic expectations and triage mindset. This entire set of hacks is emergency triage. Your aim is not to fully recharge. Your aim is to secure a short, reliable charge long enough to call for help, send your GPS, or power a light. In practice, you can often expect a small boost. In many field tests, that looks like a 5 to 30% increase, or 10 to 60 minutes of talk time, depending on phone efficiency and the source. Those numbers are conditional.
The real variable is current. 0.2 to 0.5A will do a trickle top-off. 0.5 to 1A will give faster fills. Use those numbers to prioritize. If the source delivers under 0.3A, treat it as trickle and conserve the phone aggressively. Now I'll run a quick, repeatable salvage demo you can copy without unsafe surgery. Assume you found an intact power bank with a working USB port and a dead phone at 12%. You have a multimeter and a cable. Step 1. Inspect visually. No swelling, no burns, port intact. Step 2. Measure USB port voltage with the multimeter. Reads 5.05 volts. Good. Step 3. Plug phone and observe meter under load. Voltage drops slightly to 4.95 volts and current reads around 0.6A. That's a solid emergency output on many small modules. Step 4. Phone shows charging icon. Battery climbs from 12% to 22% in about 12 minutes. You have enough to place a call and send your location. If you had left the phone on and bright, that gain would be lower. Turn on airplane mode, disable background data, reduce brightness. That stretches the charge you just made. If the phone doesn't respond, quick checklist. Polarity wrong. Rare with USB ports. Common if you tap pads. Cable faulty. Try another cable. Voltage under load collapsed. Cells or the power bank are weak. Find another source or switch to trickle harvesting. Connector insecure. Clean or support the plug. Shaky contact reduces current. Troubleshooting mini hooks you can use in the field. Anytime your measured voltage is under 4.8 volts under load, the phone may not charge reliably. If voltage is correct but no charging, check the cable and the phone's port for debris. If voltage jumps above 5.5 volts, the source is dangerous. Disconnect immediately. Practice good scavenging discipline. Do not pry into active landfills, industrial heaps, or medical waste. Don't steal. If you take items from a public area, do so within local laws and with hygiene in mind. Remove batteries that are corroded, leaking, or swollen. They're hazards, not salvage opportunities. A few final high-leverage tips to conserve charge once you have a boost. Turn on airplane mode. It stops background drain. Reduce screen brightness to the minimum you can tolerate. Use battery-saving modes in the OS. Close background apps and avoid video. Use the phone speaker for calls only if absolutely necessary. Speaker uses more power than a headset. If sending GPS location, compose the message and send it quickly. GPS locks can cost a lot of energy. Share a cached location if you have it. Safety and legal reminders again. Don't improvise battery packs without a BMS. Don't short cells and don't use visibly damaged batteries. Use fuses. Prefer pre-built, certified modules when possible. If you link to parts, buy from reputable vendors and choose modules that list input-output specs and include overcurrent protection. Wrap up. The fastest, safest path to juice is always salvage. Find an intact device that already builds in protection.
Convert only if you have the right parts and the discipline to include fuses and a BMS where lithium is involved. Harvest when you have no batteries, but you can crank, expose panels to the sun, or use heat. It's slow but reliable over time. Remember the mindset, emergency triage. You're not building a long-term system. You're extracting a few minutes or a few percentage points to get help, to move, to survive. Trash is a parts bin, and your knowledge is the lever. Use both with restraint. If you want the printable scavenger checklist and a vetted parts list for safe modules, and a gated advanced build PDF that includes full safety checkboxes for anyone going deeper, download links are in the description. Practice these skills under safe conditions. Don't learn this in a dangerous environment. Stay practical, stay safe. Get a few minutes of battery, get vertical. Subscribe if you want deeper builds and verified schematics in the download pack.